Hello friends, welcome to engineering tutorial. So we'll be discussing another question on electric field or electric field intensity. So the question is that a ring of radius 10 centimeter, it carries a charge of 5 into 10 to the power minus 9 coulomb. We have to find the electric field intensity on the axis of the ring at a point lying at a distance of 15 centimeters from the center of the ring. So here I made a video related, I think it's been 1 year back when we were discussing the concepts, basic concepts related to electric charge, electric field, especially in the electric field section. You can check it out in the electricity and magnetism playlist. I derived the expression of this, exactly this, the electric field intensity due to a uniformly charged circular ring. Okay, I derived that expression completely. How the electric field intensity due to different elements, what we did is that we took a ring first, uniformly charged circular ring. Okay, so what we did, we took small elements, small portion dl of the ring, and we found out the electric field intensity due to that on the axis of the ring at a certain distance. Then we integrated them together. What happened, each of these elements, they contributed something in the x-axis, something along the y-axis, and we resolved them and we calculated the net result. Okay, I have already derived it, so I will not waste any time to do that, repeat that same thing. We'll directly use the expression, the final expression. So here this ring of radius 10 centimeters, radius 10 centimeters, we have to find the electric field intensity of a point P lying at a distance of 15 centimeter from the center. This is the radius r equals to 10 centimeter. Okay, so the final expression which we got in that video on the electric field intensity due to a uniformly charged circular ring, the final expression is equal to, at the point P, the electric field is 1 by 4 pi epsilon 0 qx by r square plus x square to the power 3 by 2. This was the final expression. I am not deriving it here. Again, I repeat, I am not deriving it here. So please watch that video. Okay, electric field intensity due to a uniformly charged circular ring. So here simply we'll put the values. So if you different electric field intensity due to different elements are there, you know, a disc, a hollow disc, ring, like that, there are different things. So I have already derived it, so I'm not deriving it here. So we'll simply put the values here. 1 by 4 pi epsilon 0 qx, q is, it carries a charge of 5 into 10 to the power minus 9 coulomb, that is equal to q. Okay, the charge 5 into 10 to the power minus 9 coulomb. This distance of the point P from the center of the ring, horizontal distance along the axis, that is equal to 15 centimeter, equals to 15 into 10 to the power minus 2 meters in MKS or SI units. Then r, the radius of the ring, is 10 centimeter, which is 0.1 meter, 0.1 x square, 0.1 square. X is again 15 centimeter, 0.15 square to the power 3 by 2. 1 by 4 pi epsilon 0, we can substitute it with 9 into 10 to the power 9. Okay, 9 into 10 to the power 9. So the result will be, it's just put the value, get the result. If you remember this formula, great, but otherwise you would have to derive it. So here, if we put these values, we'll get the result as, it is coming around 1152 Newton per coulomb, rounding it off, okay, it's coming around, yeah, 1152 Newton per coulomb. So this is the result. So here it was, we got the result very quickly because I had already made a video deriving this expression. So please, I request you to watch that video, otherwise you will not be able to understand how we got this formula. Okay, so since I had already made a video related to electric field due to a uniformly charged circular ring at a point at a certain distance from the center of the ring along the horizontal axis. So I directly I told you that please watch that video, and I directly use the formula to get the result. Put the value, get the result. Okay. Hello friends, welcome to engineering tutorial. So here we are with another question on electric field, and the question is that a particle of mass 10 to the power minus 3 kgs and charge 5 microcoulomb, which means positive charge plus 5 microcoulomb because no sign is mentioned, is thrown at a speed of 20 meter per second, okay, against a uniform electric field of strength 2 into 10 to the power 5 Newton per coulomb. How much distance will it travel before coming to rest momentarily? Okay, the data is given. Now what we understand from this question is that we have a mass, okay, a particle of mass 10 to the minus 3 kg, and so we have an electric field, okay, let's say we consider it in the horizontal direction like this. Electric field, it goes from positive to negative. This value of electric field is 2 into 10 to the power 5 Newton per coulomb. Then we have a positive charge, okay, a positive charge which is thrown against the uniform electric field. It is thrown against the uniform electric field. I use a different ink, okay. It is thrown against the uniform electric field, okay, this positive charge, okay. So what will happen is that it will cover a certain distance, okay, it will cover a certain distance, and then it will come to rest because it is going against the field. This positive side, it will repel it, but still, as it is given some initial speed, the initial speed is how much? 20 meter per second, and it will cover certain distance, but will get retarded because it is going against the field, and the retarding force will be given by this electric field. The force of retardation will be because of this electric field. So again, combining concepts of electricity and magnetism and mechanics, equations of kinematics will solve it. So initially it is thrown against the field with initial velocity 20 meter per second. The retarding force that it will experience will be equal to QE, okay, QE, that is its charge, magnitude of charge, and this electric field value, which is equal to the charge. This object which is thrown has charge 5 microcoulomb. It has charge 5 microcoulomb. So it will be 5 into 10 to the power minus 6 coulomb multiplied with electric field, which is equal to 2 into 10 to the power 5 Newton per coulomb. That is equal to, it will be 1 Newton. That is the retarding force. And we know acceleration is equal to force by mass. But here, as it is experiencing retardation, so it will have a negative sign, which is equal to minus 1 Newton by mass of this object, which is equal to 10 to the power minus 3 kg. It has a mass of 10 to the power minus 3 kg. So it will be 1 by 10 to the power minus 3, which is equal to minus 10 to the power 3 meter per second square, retardation. This is the retardation, retarding the acceleration in the negative direction. Okay, it is opposing the motion. Okay, then we have been asked to find the distance which it travels. Let's say it comes to rest here at this point. So this distance from the initial position to final position, this we have to calculate. So we will be using equation of kinematics, v square minus u square is equal to 2as. Final velocity here, it is 0 meter per second because it comes to rest momentarily. So this one becomes 0. This is minus 20 square is equal to 2 into minus 10 to the power 3 meter per second square into s. Okay, so that implies s is equal to 0 square minus 20 square by 2 into minus 10 to the power 3, which is equal to, it is coming around 0.2 meter. 0.2 meter. That is the distance it travels before it comes to rest momentarily. Why it has been given that it comes to rest momentarily? Because once it comes to rest, again it starts moving under the influence of the electric field, because it will get repelled by this side and be drawn towards this negative side. Again it started from this position with some initial velocity 20, it was thrown, it covered this much distance, 0.2 meter. Then after reaching here, it just had a stationary position for a short period of time. Then again it started moving under the influence of the electric field in the direction of this uniform electric field from positive side to negative side. Okay, so this is the whole thing. Okay, so again it involved concepts of basic concepts of electric charge, electric field, and equation of kinematics, final velocity, square of final velocity minus square of initial velocity equals to 2as, acceleration and distance covered. So we use that to get the result. Okay,